Hello everyone, welcome to day 5 of May Leetcode challenge. Today we have question number 225, which is implement stack using queue. We have to implement the stack and that should support all the function of a normal stack, that is push, top, pop and empty. We have to implement the myStack class where the function void push have the parameter x which pushes the element x to the top of the stack, integer pop, function pop remove all the element on the top of the stack and returns it. Function top is of integer type that returns the element on the top of the stack, and boolean empty is a function that returns true if the stack is empty or false otherwise. So let's see how to implement it and how will it work. So the first thing is, we know that stack works on the principle of last in first out, whereas queue works on the principle of first in first out. So if we have to implement stack, let's see how the stack works on these following operations. So if we have to push 7 in the stack, it will go over here, and then if we have to push 9 in the stack, it will go above it. Then we have to push 6, which will go over here, and push 2, which will go over here. Now it shows the function top, and this property of stack is last in first out. So at the top of the stack we will see the element 2. So at the top of the stack we will have element 2. Now pop. So pop means we have to remove the first element from the stack. So 2 is removed. Now we check the top. Now the top is 6. And again we have to pop, so we have to pop the last element, that is last in first out. And again if we have to delete it also, this was the recently added one, so this is going to be deleted. For the stack, top is this one because stacks moves in the downward direction. And top, now the top is 9. So this was the functionality of stack. Like whatever you are pushing last comes shows like at the top of the stack. And the first thing, if we have to implement stack using queue, the first approach can be, we can use two queues, q1 and q2, and whenever there is a push operation, we add the element in q2, and if there is any element present in q1, that we shift element by element in q2, and then the third step is we will swap both q1 and q2. And if in order to we have to perform the pop operation, then we remove the top of the q1. So let's see how can we implement stack using two queues. For example, first we have the push operation 7. So we will push 7 in our q2, and then we will put all the element that is present in the q1 and q2. So as of now q1 is empty, so let it be, nothing to put in the q2. So we will follow the third step, that is swap q1 and q2. So if we are swapping q1 and q2, that means that now 7 will come over here, and now we will push the next element, that is 9. So when we push 9, again we will follow the same step. We have added 9 in q2, then we put all the element present in the q1 and shift it to q2. So now 7 will come over here, and then we have to swap q1 and q2. So while we were swapping q1 and q2, q1 is empty because 7 is shifted there, and now when we have to swap it, so 7 and 9 will come to q1. Again we have to push element 6, so element 6 will go to q2, and we have to put one by one all the element of the q1 and q2. So of course it's following FIFO. So first 9 came, so 9 will pop out and will go in the stack q2, and then 7 is added in, so we will remove 7 and that will come over here in the q2 stack. And the third step is swap q1 and q2. So again, as this is empty again, so 7, 9 and 6 will again be added to the q1. So and now we have to push 2, again the same steps will be repeated, 2 will be added to Q2. All the elements that are present in Q1 will be moved to Q2. So first, as it is FIFO, so first element was 6, so it will remove and it will be added to Q2. Now the first element, like after removing of 6, the first element is 9, that is removed and added to Q2. And now after removing 9, 7 is the only element remains in Q1, so that is also removed and added in the Q2. And now we have to swap the third, we have to perform the third step, that is swap Q1 and Q2. So all the element present in the Q1 is now will be added to Q2. 7, 9, 6 and 2. So this is 7, 9, 6 and 2. And now when we will ask for the top, of course it's using the FIFO pattern. So first in, first out. So first over here is 2. So we will get 2 because it's recently added. Then if we have to pop it, so the first element will be pop out. Now our first or the top element will become 6. Now again they are asking for top, so now we will return 6. And then again for pop, if we'll pop it, now the top will become 9. So now the top, if they asked, it is 9. And again if they asked for pop, then we will pop, the only element remain in this is 7, and that is what the top. So this is how like we have created a queue to a stack. We can see the same input we are getting, output we are getting when we have used Q1 that perform all the functionality of the stack. This is one approach of doing it. This was like I did something. Okay, let it be. I'll write it again. So the time complexity of this algorithm is, we are using Q1 and Q2. So one Q1 take O of n and the other Q take the n space complexity n and n. So the space complexity is 2n, and for the time complexity we are adding the element, swapping it. So all of this is done, and we are putting the element from Q1 and Q2. So again that means it's traversing through all elements. So the time complexity is O of n and the space complexity is O of 2n, and then we are using the extra time for swapping Q1 and Q2, so it's almost approx equals to n. So the space and time complexity is n. Implementing stack using queue is that we can use single queue. How to do that is, if we perform these again operation on the queue using a single queue, then we will first push 7 in the queue, and then we will check if the size of the queue is greater, if the size of the queue minus 1 is greater than 0. So over here the size of the queue is 1 and minus 1 is 0, so it's not greater than 0. Then we will again perform the second step, that is push 9. We will push 9 and then we will check the size of the queue. Now the size of the queue is 1, size of the queue is 1 is y, basically the size of the queue is 2, but we have to use it, we have to convert this queue in the form of the stack. So what we will do is, till the size is greater than 1, we will remove the front element and we will add it on the top of the stack, top of the queue, so that it will form the stack. Why? See the logic. If we will remove this and add it over here, now the latest element which we added, the last element which we added is 9, will become our first element, and this is how it's going to perform. It will slightly going to perform or give us the functionality of the stack. So let's see it again how this is happening. As we got 7, we will push over here and we will check the size of the queue. If it's 1, we will do nothing, we will push the another element, 9. Now the size of the queue is 2. Now we will take size of the queue minus 1, that is the single element, we will remove it from here, and then again we will add it in the same queue, and then we will perform a next operation, push 6. Then again we will push 6. Now the size of the queue is 3. Now we will take last two element and we will remove one by one. So first 9 will be removed and added in the queue, and then 7 will be removed and the added in the queue. So basically our queue will somewhat look like this: 7, 9 and 6. 7, 9 and 6. Then again when we have to add 2, what we will do? We will add 2 over here, and then the size of the queue is 3. I mean the total size is 4, but what we have to do is we have to take 1 minus this present size, so the 3, and then we will remove the first element of the queue and add it again. Then we will remove 9 and we will add it again in the queue, and then we will remove 7 and add again in the queue. When this all operations are done, our queue will somewhat look like this, which have the elements 7, 9, 6 and 2. This is our queue. And when we will perform the top operation, now the top is 2, and this is where it is behaving like the stack, because in the stack only the last element becomes a first element, but over here we already know that our first element was 7 and queue behave like first in first out. But as we have performed this operation, so because of this our last element become the first element, and now when we'll pop it up, this element will be popped, and now our new top is 6. So that is what it's going to come over here, and when we will again pop it, then our new top will become 9. And this is how we are going to implement stack using queue. So let's code it up. Thing is, first we have to make the queue. So private queue of integer. Okay, initialized it. And then we have to perform the push operation. So the first thing is add the element in the queue, check the get the size of the queue, that is queue dot size, and -1, because we have to, in order to make it in the form of the stack, and then till the size is greater than 0 we need to remove the element from the queue and add it in the same queue. So queue dot add queue dot poll, and then reduce the size, and in the method pop we just simply have to return queue dot poll, and top is also simple, we just have to return queue dot peak is boolean empty, so we have to return queue dot is empty function. It will give true or false. If it's empty it will give true, if it's not empty it will give false. And if we talk about the time complexity, then time complexity is big O of n. Why? Because see, again, in order to make it stack, in order to make the queue work as a stack, we are just again removing the size -1 element present in the queue and then again adding it. So that is why that process is taking O of n, and the space complexity is also big O of n because we are using queue. Let's run it. It's working. Let's submit it. Okay, so we are done. Thank you.